Mathematical logic uses many of the large number of symbols that exist in mathematics. Most of these definitions also have multiple symbol representations. Some of the common or key symbols used include implies, and, or, not, if and only if, for all, there exists exactly one. There are, of course, a number of other symbols in use. One of the reasons for using symbols is to abbreviate written language when writing or formulating equations or propositions. It is also a means of constructing a uniform language to express ideas.
Hi, my name is Brian. What is a proposition? A proposition is a declaration sentence that is either true or false. How is logical are relevant to computer science? It is fundamental to computer science as calculus is to physical sciences. It is important in areas like software engineering, programming language, database, computer science as discrete as architecture.
What is a truth table? It's a mathematical table used to connect using for Boolean algebra, Boolean functions, and proposition calculus to compute all the function values of the logic expression on each functional agreements. How would we use it? We just use two sentences. For example, we got here, if it's raining, then I'll stay at home. We can specify if it's raining as a P preposition, and then I'll stay at home as a Q. And then we will say B applies to Q. And we can do a truth table based on B implies to Q. So we got B and then Q. So B, there's two positions for it, which is either true or false. So we will true, and Q, if that's true, then Q would be true. And then we go to the next one, that would be true, and maybe Q would be false. And then the third one, P would be false, and Q would be true. And then the fourth one, where P is false, and Q is false, which is both of them false. So what we're doing here, we're saying, it's raining, and I'm staying at home. Now, it's raining, but I didn't stay at home, I went out. And then he says, it didn't rain, and I did stay at home. And that one says, it's not raining, and I didn't stay home. And then, we just apply P implies Q, where P implies Q. So, it's raining, and I stayed home, which is true, ends up with true. Now, the next one says, it's raining, but I didn't stay home. So, the whole proposition of Q was false. So, it gives us false answer. And then, the next one says, it's false, but I stayed at home. So, it didn't rain, but I stayed at home, which is the main of it was the Q ends up staying at home, which ends up true. And the fourth one, it's false. It didn't rain, and I didn't stay at home. So the whole sentence was based on false. So we put here, false. Second law we have here, distributive law, which is, it says, if B or Q and R, it's same as when you say B or Q and B or R. Or you can say the other way around where it's B and between the brackets Q or R. It's equivalent same as when you say B and Q or B and R. So it works the same thing when you do algebra multiplication. The next one we have is De Morgan law, where he says not B or Q. So when you put this not, and then between the brackets B or Q, it's the same equivalence as when you say not P and not Q. So we just shift that not to for each of them, and we change from or to and. Same as when you do the same thing, but instead of using or, we use and, when will be equivalent to not P or not Q. Now, as we can see here, we have a question.
Depends.
It says
How much?
if it's not Q and B implies to Q, all of them, all that sentence implies to not B, it should be always true. Now, we can do truth table where it will take us a bit longer, or we can simplify it and see if it's actually that equivalent to the tautology. And we can use, as we can see here, the law. We just discussed it before. Now, to shift them, we use the implies first, and as we can see here on implication law, where we got implies and we just shift it to not P and Q. So in here we would say not the whole this argument, which is implying to P, and then or, we change this from implies to or, and then we move inside the first argument, the first proposition, where it says P implies Q. We just say not P and Q. So we simplify it and we go to the next step. We can use the second law. And in here, we just use De Morgan law, where we shift everything inside the brackets. So we say not, and then in here we have not P, I mean Q. It would be, as you say, not Q is same as Q. So we leave it as a Q, and then we use the word we use the symbol or, because we shift it, we have to swap around, and then we say not between these brackets the whole sentence, which is not P and or Q. And then we just put pretty much all of them the same. And we go to the next one to simplify it more. So in here we have Q or, and now we shift not P, which is P, and not Q. And then we just leave that down, it's exactly the same. Go to the next one, we will use descriptive law, and we say here not Q or P, we put them in a bracket, and then we say not Q or not Q or not Q, which is down here, and we use the word we use the symbol and then we just bring that down exactly the same, and then we go and simplify it more and more, where we say not Q or P, and then put the brackets and. When we say Q or not Q, it's either Q true, which is the whole that statement is true, or we say not Q is true, which is again the whole statement is true. So we end up with this is always true. So we can actually take it down and we simplify it more. We go to the next one where it says Q or B or not B, which is that one. So we bring it down here. And then we use the descriptive law as well in here, where we says Q, where we says Q not P or P, which is literally give us not P or P, it's always true. And then we simplify it to the last one where it says Q or true, which is this one's always true because it's not P or P. So if P true, the whole statement will be true. If B was false, the whole statement will be false, which is can't be, because one of them is going to have to be true. It's either not B is true or B is true, which is always the best true. And then we go to the last one which says the Q or true, which is always true. And that's how we get statement that it's tautology.